Hi everyone, today we're going to be talking about spring potential energy. This is the potential energy stored in a stretched or compressed spring. Now imagine we had this spring here, and then we stretched it. At the maximum point of the stretch, the spring has only potential energy, but then we can release the spring, and it will move back towards its equilibrium position with some velocity v. That means the potential energy gets converted into kinetic energy. The same thing happens when we compress a spring. At its most compressed point, it has all potential energy. But when we release it, the spring will return to its equilibrium position, and it will do this by converting potential energy to kinetic energy. Now, how do we calculate a spring's potential energy? Well, you can use this equation, which says that the spring potential energy is equal to 1/2 kx squared, where k is the spring constant, and it has units of newtons per meter. X is the displacement from equilibrium, and it will have units of meters. And USP is the spring potential energy, and it has units of joules. And one important note for when you're doing questions on spring potential energy: if you need to find the spring constant K, you can use forces. Because remember, the force of a spring is equal to negative Kx. Now let's jump into a question to practice what we learned. In this question, we have a spring scale, and it uses a 10 centimeter long spring. If we hang a 500 gram weight on the spring, it causes it to stretch to 13 centimeters. And we want to know what is the potential energy of the spring. Now the first thing I do is write my spring potential energy equation, which is equal to 1/2 kx squared. Now we will need to use forces to find the spring constant K. So the first thing I'm going to do is draw a free body diagram to represent the weight. We know the weight has the force of gravity pushing down on it and the force of the spring pulling back up on it. We also know the net force is equal to 0, because once the weight has stretched the spring, it doesn't move up or down. Now we can write our F net equation, which is the sum of all the forces acting on the weight. So we have F net is equal to the force of the spring minus the force of gravity. We can replace F net with 0, we can replace the force of the spring with negative Kx, and we can replace the force of gravity with mg. Now all we need to do is rearrange and isolate for the spring constant K. And that gives us this equation, which says K is equal to negative mg divided by x. The mass of the weight is 0.5 kilograms. The acceleration due to gravity is 9.8 meters per second squared. But what is x? Well, we know the spring stretched from 10 centimeters to 13 centimeters. That means it was stretched by 3 centimeters. But if we just plugged 3 centimeters into our equation, then the spring constant would be negative. And that is not possible. You have to imagine that the spring's equilibrium position is the 0 point on a number line, and then the spring was stretched down by 3 centimeters. So its final position on our number line is negative 3 centimeters. And now remember, we always have to be working in meters, so we would use negative 0.03 meters. And with that, we can do the math, and we see that the spring constant K is equal to about 163 newtons per meter. And now we have everything we need to solve for the spring potential energy. We just need to plug in the values for the spring constant K and x. And remember, we just solved for x, it's negative 0.03 meters. And then when we do the math, we find that the spring potential energy is equal to 0.07 joules. And that's how you use the spring potential energy equation. Thanks for listening, and good luck with your studying.